Hi. During these last few weeks in AP Physics class, we have been learning about light, waves, and the importance of astronomy and the sun in Earth. For the project, I chose to create a spectrometer, which is an instrument that measures a spectrum, which are all the colors that make up light, specifically sunlight. I chose this because I wanted to prove how the spectrum of the solar light changes throughout the day, and also how sunlight encompasses a lot of colors. As you may know, light is a wave, so it travels through a periodic manner, and the point from crest to crest is called the wavelength. Various colors have different wavelengths, and that is what distinguishes them from one another. The phenomenon that creates light is the electrons within the atoms. When these electrons get excited, they move from level to level in different orbits. And when they go back to their original level, they release energy in the form of photons, which are light particles, creating light. As I mentioned before, the wavelengths of each color relate to their specific color. And the visible light spectrum varies from 400 nanometers to 700 nanometers, 400 being the smallest wavelength, which corresponds to violet color, and 700 nanometers corresponds to red color, being the greatest wavelength in visible light. Referring back to the sun, one of the most interesting findings that I encountered during my preliminary research was that during different times of the day, the spectrum changed depending on the sun's altitude. This is due to the different amount of light passing through the atmosphere. So as the sun is lower, more sun hits the atmosphere, which causes light to refract further and therefore show more color. So to prove this, I decided to create my own spectrometer in order to measure the different spectra of the sun throughout the day. I researched about material that could refract the light of the sun and found out that prisms had this ability as well as gratings. A grating is a material that has a periodic structure, similar to waves. Therefore, a CD could act like a grating. Using the CD as my lens, I was able to refract the light of the sun into its different components and visualize it through the spectrometer. So here I have the final products of the spectrometer. And to do this, I used the following materials. I used aluminum foil, I used duct tape, a can, a Pringles can specifically, and also I used the lens that refers to the CD. And within this spectrometer, I have a sheet of black matte paper in order to prevent the light from reflecting within the spectrometer. To build a spectrometer, first I had to empty the content of the can. Then I threw away the cap, the plastic cap, which would correspond to the top part of the spectrometer and would be completely clear when taking everything out of it. On the bottom part of the can, using scissors or a knife, I cut out a 1 by 1 inch square in the metal part of the can. Then, using a clear CD without the metal covering, I would cut out a part of that CD and using duct tape, paste it really tightly over the 1 by 1 inch square. On the other side of the spectrometer, I would outline the diameter of the circle on the aluminum foil and using duct tape as well, paste it really well around the bottom part of the can. Then, using the same knife or scissors, I cut out a 1 inch line, thin line to allow little light to come in, that would be parallel to the grating of the CD. So if the CD is like this, then this line would also have to be like this, as shown here. To use it, you simply go outside when it's sunny, or using an alternative light source, like for example a flashlight, you would use this part and point it towards the light source and look at it through the CD grating, like this. Supposedly, As the light comes in, it should refract and you should see the different components corresponding to that specific light source. The link below is a presentation created by me that includes different pictures taken by me with my own phone of the different light sources that I experimented with. With these pictures, I was able to compare and contrast the different light spectra that were emitted from different light sources.